Hi, today I'm going to provide you with a quick review and a few fun examples to help you understand levels of measurement. So if you recall correctly, we've got two main categories of levels of measurement. So variables can either be split into categorical variables or continuous variables. So the categorical variables, which you probably know about, there's three. So the first one is a binary variable. So in a binary variable, it's inherent in the name, you've got a binary outcome. So for an example, a person could be dead or alive, and in SPSS you'd record that as 0 or 1. So, so for the sake of your data analysis, you'd probably use, Pearson chi-square, something like that. So you'd have something that could deal with binary variables. So, as you can tell, probably quite restrictive in terms of data analysis, often used for things like gender of participant, etc. Then you've got your nominal variable. So as the name implies, it's nominal. It's to do with names and names, yes. And so it can be more than two categories, but there's no inherent order to the categories. So say for an example, you might have color of clothing participant wore: pink, blue, yellow. You can't break up those categories any further, and there's no inherent meaning to them. There's no order. There's no pink as first, blue as second. So nominal is, again, used mostly in non-parametric statistics. Then we've got an ordinal variable. So ordinal is a bit different because the categories don't give you any idea of the space between each, but they give you an idea of the order. So say for an example, we might have 5 doses of ecstasy to give to our participants in the world's greatest experiment. So we've got a low dose, a medium dose, a high dose, and a very high dose, and a heroic dose. So we've got these 5 doses, and unfortunately, our dealer for the experiment didn't tell us the dosage of each. So we've got no idea the difference between them, but we do know that this one's low, and this one's medium, this one's high, this one's very high, this one's, heroic dose. So, but we've got no idea of the gap between these two. And so really the low and medium could be 5 milligrams apart, while the very high and heroic dose could be 100 milligrams apart. And so an ordinal scale is, what's generally used in, say, like the depression inventory, the empathy quota, things that, say will range from totally disagree to I totally agree, those kind of things. And you can run these in an ANOVA or regression, but you generally want a minimum of 5 options is the rule, but I would suggest trying to avoid using them in ANOVA if you can. The other main type of variable we have is continuous variables. So the entities get a distinct score. So there's 2 kinds of continuous variables. There's interval and ratio, and the difference between them can be a bit hard to wrap your head around. So I'm going to do my best to try and explain it to you as simply as possible. So an interval variable means that there's equal intervals on the variable being represented. So there's equal differences in the property being measured. So let's use the example of temperature. With temperature, the difference between 15 degrees and 30 degrees, we can say is 15. It's 15 units of temperature difference. And the difference between negative 15 and 15 degrees is 30 units of temperature difference. However, we can't say that negative 15 degrees is negative 1 times, you can't make any multiplication. You can't say that, say the difference between 15 degrees and that is 2 times. So it's not twice as hot. It's just 15 units of measurement difference in temperature. And so the 0 point doesn't have any real meaning. It's a completely arbitrarily made number. It doesn't mean anything. However, so that's interval. However, with ratio, you can say there's a meaningful 0 point, and that is the main difference, really. Because, say with height, if your height is 0, you don't have height, you don't exist, so it's meaningful. So we can use the gauge of 0 as a meaningful number. And so that means, say, the difference between being 30 centimeters high and 60 centimeters high is 30 centimeters. And then we can say that it's, 60 centimeters is twice as large as 30. And so, basically, they're very similar, and these are what you generally would want to use in all parametric analyses.